Hello, everybody. This company is redefining renewable energy with installations that float serenely on water bodies, like you can see already in the background. They are harnessing the power of the sun with their patented membrane system for floating solar panels. This is amazing. Let me introduce Ocean Sun. Hi, everybody. Welcome to another episode of Builder Nation. I'm your host, Sam, and today we are joined by Børge Bjørneklett, CEO and founder at Ocean Sun. Welcome, Børge. I hope I pronounced that right. I'm sorry. Thank you for joining us today. Can you please introduce yourself a little bit?
Thank you, Sam, and thank you for having Ocean Sun and a company on your amazing podcast series. Yes, so my name is Børge Bjørneklett. It's a tricky name to pronounce, but you have the with O with a slash across the Scandinavian letter. So yes, I'm the founder and the CEO of company Ocean Sun, and our main product or this initiative in the company is the floating solar energy. And perhaps not everyone is familiar with the concept of floating solar, but it's actually quite old invention, so to say. I think it's actually the first floating solar farms was in California on a vineyard. Was a farmer that put some solar panels on a floating barge on an irrigation reservoir, and then he had floating solar. So, but the need is coming out of these share surfaces that are needed for the large solar farms, and increasingly difficult to find these areas close to the consumers. And then the idea is then to utilize water bodies. It could be large lakes, reservoirs, or even in near shore coastal ocean site.
Well, I mean, I have to say that's very cool. I didn't actually know this was a very, I don't want to say common tech. I don't think this is common, but at least I want to say it's not new, right? I didn't know that. So thank you very much for shedding a little bit of light on that sort of background or of where it comes from, right? But I do have a question. In your experience, how was this? What is the reason why this was born in the first place? Like we already know, it can be used in lakes, large water consoles, or even near shore, right? But why was the need for this eventually realized? Why did this come to happen in the first place?
I think it was rather the opportunity that emerged when if we could solve this problem in a good way, and many in our company have our background in solar cell and module manufacturing, but also from the Norwegian maritime offshore sector. So when you combine, let's say, those two industry areas, then we had the opinion that we were well suited to come up with this idea and this new invention and try to solve it in a better way than the, let's say, mainstream type floating solar, which is essentially small polyethylene floats or buoys that are interconnected, and when you place a solar panel on top of each of them,
right?
And that is the mainstream type. But we have a different approach to it by using these large surface membranes that is resting directly on the water surface, and then they are suspended in these large flotation rings. That is also very kind of a derivative from Norwegian fish farming industry, where you have the farming of the trout or the Atlantic salmon.
So is floating solar, was it originated in Norway actually, or did you sort of adopt it from somewhere else?
Yeah, well, it is developed in Norway and on the west coast of Norway, and by utilizing some of these flotation rings that were leftovers from fish farming,
right.
And then we use the same anchoring and mooring principles that they were using, but rather than having this fish cage or this pen, underneath the flotation collar, we put the surface membrane inside, and then
Wow.
the solar modules are resting horizontally directly on this membrane, and then you achieve a strange effect that you can dissipate the heat generation in the solar module into the water body. So it's a direct thermal contact with the water, which is much more efficient than the traditional air cooling of solar modules.
Yeah, I mean, that's actually true. I didn't even consider the fact that it's essentially having like a cooling system straight into the solar installation. And I definitely I really want to talk about the tech that you built to actually make these floatable, solar panels really useful, right? But before we reach that point, I actually want to talk about the differences between this and a general, sort of traditional installation for solar panels, because there are many differences. Not just the fact that they're floating instead of on a rooftop, for example, but they're also flat. It's also a very important detail, and they are, I would assume, constantly moving because shores and waves and winds. So, what are some of these? What are some of the main differences and challenges that come with floating solar panels, and how do you tackle those challenges?
Yes, so at sea or a large lake, for that matter, you have the three environmental loads. It's wind, wave, and current.
Right.
So you have to design for those three factors, and then normally, at least that on the towards the poles, you need to tilt the solar panel quite a lot to have its ideal position is perpendicular to the sun. So, but if you start doing this with thousands of solar modules, you create a tremendous wind drag. So in order to cope with areas with strong wind, it's very beneficial to keep them horizontal, flat, the water.
Right. I mean, it definitely makes sense in terms of the wind. And is there a difference in the terms of the productivity or the efficiency for the panels? Because traditionally speaking, they have to be oriented in a specific angle, aiming at a specific, point. So
yes, it really should be perpendicular to the sun, and the best, let's say, ground mount systems are those that have so-called two-dimensional tracking, so you have motors moving the solar panel directly towards the sun all the time. But these systems are partly complicated, and also the mechanics is vulnerable if you place things like that at the sea due to corrosion of the gears and what have you.
Right.
And also when the solar panels become very low manufacturing costs, the prices of solar panels have dropped dramatically. So then it's more a challenge to provide large surfaces, really, to the deployment area. Because the trackers, now more, I think it's quite popular with the one-dimensional tracker. So you have just the panel pivoting around one axis. Which is done quite a lot in so-called ground mount systems, but on water bodies, we figured out that okay, let's just make huge surface area, large deck, and with a high number of solar modules, and thereby
so you factor in sort of that loss of efficiency because they're not going to be perfectly adjusted, and you make up for it in volume, in term on amount of panels. Well, that's actually pretty clever. Now I have a final question before we get into the real bread and butter, into the actual floating system, right? Which is who can really take advantage of these type of solar panels? Like, this is, for starters, I believe, not meant for like general public or maybe in factories or industries. Who takes advantage of these type of systems?
You have different user groups. I would maybe be split into I think at least 4 different groups. You have The regions, let's say Latin America, Brazil, Colombia, Southeast Asia, where you have dense rainforest,
Right.
very jungle, you know, and then it becomes really costly and not really acceptable to do the deforestation to build the large solar farms.
Okay, right, yeah.
Because we are talking about tens and hundreds of square kilometers of area for big power plants. And then if you can then utilize the water bodies, the large lakes and such, it's very beneficial.
Yeah.
Secondly, you have the hydropower dams, the reservoirs.
Right.
Then it's very beneficial to have the floating solar because you then already have the grid infrastructure already in place from the power station. So you have a very short transmission line into existing grid. Often when you plan a ground mount solar farm these days, you have to go out in some very desolate place in a desert or some, and sometimes the transmission
Right.
line is as expensive as the solar farm itself. So it's a huge benefit to sit on the hydro dams, and you also then prevent the evaporation of fresh water from the surface of the dam, which is lost into atmosphere, you know. And these membranes is very efficient in the prevention of the evaporation where they are situated. And it can also reduce algae blooming because of the photosynthesis, and then also less maintenance on your hydropower equipment, the turbines, and the cleaning out of so-called macrophytes or water plants.
Yeah.
And a third area is if you think about the large cities like Singapore, the city of Singapore, you have high population on very relatively small island.
Right.
The cost of land is tremendously high. They have already used much of the rooftop space for solar, and it's competing with terraces or gardens on top of the rooftop. So, but they have a large surface area on the sea near shore that can be utilized for the large floating solar farms. And perhaps one of the few options for producing renewable energy in those places.
Right. And what would you say was the fourth? You already mentioned these three.
Yeah, I think yes, the fourth. I think that would be the islands, the island communities. You know, think about if we have Indonesia, 20,000 islands, the Philippines, 7,000 islands, archipelago, where you don't really have a very good energy distribution grid. And most of these populated islands that they are generate their power on diesel generators. First of all, it's extremely expensive for the islanders, but it's also very polluting, and many of these countries also have a high degree of coal-fired thermal power plants.
Right.
While at the same time they're sitting on tremendous solar resource where you can place these floating solar farms near shore, directly in feeding in, and in combination with battery or pumped storage facilities, they can cut the energy costs tremendously. And this is talking about the entire Pacific region, you know, and also Caribbean and other islands.
Wow.
Yeah.
Right. I mean, it definitely makes sense that this would be the perfect substitute for traditional solar panels in places where, generally speaking, I would sort of summarize it up with very short or very low surface area where to install the panels, or with a very, very expensive and long sort of transmission line. It makes sense.
Yes.
So Now, with this, I do have a couple questions that arise from this. In fact, I want to tackle three different topics about this precisely because they seem very interesting challenges. The number one would be in the terms of installation, how easy or hard is it to install a floating solar panel, farm? Second would be maintenance, and third would be how does it affect sort of the ecosystem, if you will, in the lake, like do fish, like if fish litter, are they affected, right? But before tackling those that I already have saved up here and I'm gonna touch them, I want to learn how these panels float. Like you already gave us this overview, right? Like they have these buoys pretty much, and they are and the panels are stacked on top of them, and so that's how they float. But looking at the background, at the picture you have in the background from you, that are sort of like those four circles actually. They seem to be very specifically organized in sort of a grid, and then the ring around them, which is black, right? That is when you mentioned that you sort of saved from this old fisher, like this fishing industry, I believe. Just what is the science behind these floating things? It's amazing.
Yeah. Yes, and it really is a very strange vessel, if you can call it that. So, because first of all, this flotation ring or the buoyancy, the sort of uplift, it sits in these pipes. These are pressure class pipes with high purity, high density polyethylene pipe of a certain type. It's the same that is used in water supply and even oil and gas transportation pipes.
Right.
And then this membrane, it's called a tension membrane, or it is a technical textile. It's very similar to what you are using as a roofing material on many buildings. You also have them in big stadiums. It's a woven reinforcement. There's textile inside, and then it's coated with the thermoplastic material on both sides. Similar to what you can have in these rigid inflatable boats and that type of fabric.
All right.
The strange thing is that we discovered and not really knew the effect of it was almost accidental. And if you put a very large disc or on the water surface, you change the surface tension in a way. It's almost like pouring oil on water. You maybe heard about this effect on oil on troubled water. So what happens is that this prevents the breaking of waves. Okay. And you then end up with only the harmonic wave traveling across the membrane. And
right.
And then you suddenly have this huge installation surface, and you can actually walk on top of this. This was not, it was unknown for us in the beginning actually, but it's completely changed the surface tension, and you can then actually walk around on a soft surface. And then to your first question, if I remember correctly, how to install it.
Right. Yeah, actually, let me get back to this. Yeah, first of all, I actually want to mention a couple things that I find really cool. It's interesting how all of the tech, pretty much that you described, is sort of comes from somewhere else, except for, of course, this last bit that you mentioned, right, which is something that you barely discovered. But I mean, I'm very curious. Is there like how different is the technology between these, for example, and say for example the actual fishing industry, right, where they have like these massive rings sort of to catch fish, for example. You mentioned you sort of took those from the fishing industry, but how has the technology evolved from there? For example, you have a patented membrane technology, right, that you developed. So how much has this evolved over time? How different and how unique is this tech already?
Yes, it's a kind of putting together different, completely different technology and purposes. In fish farming, commercial fish farming or aquaculture industry, as it's called also in Norway, was starting to become a big industry. It's almost 30-40 years ago. And in the beginning, it was just a matter of building large cages or enclosures in the sea that where you were essentially feeding the salmon and growing it into large size.
Yeah.
And initially, those were built out of galvanized steel, and because that was the go-to material. But later, it was discovered that due to the motion and the waves and the forces acting on these cages, you had problems with fatigue, material fatigue, and also corrosion. So there was a limited lifespan on these structures, and there was clear limitations on what type of sea state it was possible to put them in. And then it gradually developed into using more polymer materials, these high-density polyethylene, which is a strong thermoplastic, and also to make them circular, because then it's more resilient to different wave directions and wind directions, and also it acts partially like a wheel. So if your mooring anchoring forces translates very favorable inside on the rim on a wheel. And so that is now more the favored type of fish, large fish cages. They are constructed out of these flotation rings, and where you have a pen or a cage hanging under them. So what we do is essentially we just remove this traditional fish cage or the fish pen and only utilize the surface with these textiles, and then put the solar panels on the textile, and then achieve this effect with the thermal connection also with the water, because the membrane is relatively thin. It's about 1 mm thick.
Oh no, that's very thin, yeah.
Yes. So and that enables the heat to
dissipate very, very easily.
Yeah. Yes.
Wow, that's very cool. Thank you very much for sharing that. I always like asking these type of questions sort of for context or background, especially because, I mean, you have a history as a scientist and in research. So it's a very cool answer. Thank you very much for that. But now, yes, let's jump into the first part that I really want to tackle, that I'm very curious about, which is installation. Now, just for a little bit of context for anybody who might not be familiar with how a typical solar power installation works, right? You have, you know, maybe you can have your sort of fixed angles with just aluminum bars or metallic or galvanized steel sometimes if the conditions are a bit harsh or whatever. Or then you have, for example, your rotary ones, right? But generally speaking, those are very simple to install. You just cut the pieces to the size you need them. How do you install these floating solar panels? How does it look like?
Yeah. So to explain this, I myself, I was 15 years ago, I was in charge of the solar module produced in the design for it in a large solar panel producer. So the design of the traditional solar panel is not really changed since 1970s. It's essentially a laminate or a glass surface, if it's the glass type solar panel, and then there's a frame, which is back in the day sometimes also steel frame, but now today it's an anodized extruded aluminium profiles in the frame. And the whole purpose of that frame is, partially to protect the edges of the solar panel, but also to provide as an installation point for clamps. You have 4-point clamp, you're positioning these 4 clamps in special positions, and then you use a bolt and the washer and the 8 Newton meters of torque, and this is very much specified in international standards. Something called IEC 61215, which specifies exactly how a solar panel should be installed. and there are some variations in underwriters laboratory in UL in the US, but very similar methods. So what we did in Ocean Sun is a quite radical or disruptive way. So we take away the entire frame, so we end up with just a frameless glass type solar module, which has a very good resistance to water ingress.
Do they still have the templated glass panel to cover them?
Yes, it has a hardened glass front and also back side, so it's like a sandwich, and it also uses a special so-called encapsulant. This is the adhesive that is in between these glass panes, and inside there you have your solar cells that are encapsulated in this. And and you have your junction boxes then mounted on one of the sides of this, with the plus and minus leads going out and the diodes there. And so what we do is to replace the traditional frame with some there are different methods and ways to do this, but one that we are using a lot is so-called Cader principle. And this is the same if you've been on a sailboat, how the sail is attached to your rig. So the sail is then slid up in the mast and also fixed to the boom of the rig. And this is very strong, very old invention to gives a very strong mechanical fixation of the sail towards your rig. And the same principle is done then on the long edges of these solar panels, so they are then affixed to the membrane with that same principle.
Wow.
And actually a much stronger mechanical fixation than your traditional 4-point clamp system.
Right, because there's a lot more surface in touch with each other to stay.
Yeah, yes. And,
right, that makes sense.
And in addition, you also have the full hydrostatic pressure on the back side. So the back side of the solar panel is completely flat. We put the junction boxes on the sunny side of the solar panel, and then it's a completely flat, full hydrostatic pressure from the water. So it's actually a very good, both mechanically and thermally, installation of a solar panel.
Okay, that's cool.
Because you don't have these vibrations that can occur in a solar installation. You can have, when you have wind, you have sometimes
that they sort of ramble.
Frequency vibration, in which can introduce microcracking, and also snow load, for instance, is also known.
And how does the deployment look like? So do you install the panels like? Do you first deploy the membranes and then you send a team in boats to place the panels one by one, or do you install everything like on the ground and then deploy the whole thing to the water body?
Yeah, so, we typically then we go to a site and then you do the welding of these rings. That is a so-called butt fusion welding machine. It's just heating the ends and then compressing them.
Yeah.
And then you make it into these rings. And then you take the ring and you then take out your membrane up to 75 meters in diameter. So those membranes, that's the maximum that you can fit in a 40-foot.
That's big.
Yeah, it's I mean, close to 4,000 square meters on one disc. So we can now have 0.7 megawatts of power. Peak power on one of the
on
discs.
One module, right? On one disk, right?
Yeah, on one circle.
Wow.
And we unfold and roll out this membrane, and then it's attached to the perimeter ring. And, and then you have your installation surface. It's almost like a big flat rooftop, and then we can just have it on the beach next to some, and then you have truckloads lifting pallets out, and you can even turn it around, so the walking distance for the workers to carry all these panels becomes shorter. So you can actually have a very high installation pace, which is important in the very big solar farms where you have to install.
Yeah, I mean the one they have in the back right now, it is 4 rings, and I mean these rings seem pretty big. Okay, I'm just comparing sort of with the background. Are these like the highest size, like the 75 meter in diameter rings that you have?
These are 70. These are half a megawatt on each.
Okay.
So it's a 2 megawatt pilot. It's 2 megawatt solar installation. It's almost 6,000 solar panels.
Oh, jeez,
it's more than 6,000, and it's about, I think, 30 tons of solar panels on each membrane.
Wow.
So, and then you can, on the picture you can also see the power transmission going towards this dam and down to the powerhouse, and then into, this is in south of Europe, in Albania. So it's delivering power to the Albanian grid.
Wow.
So,
all right. So we already know how you deploy this. It's actually very tricky and very clever solution to how it is, to how you install them. But now I have a sort of a middle question in between this and maintenance, right? Which is, how do you make sure these floating panels don't drift away? Like, I mean, I completely see, I can understand that they are connected, of course, already with the ground, right? Like, we can see the cable right there in the back, of course, but how do you make sure that they stay in place, really? Because I can think, or I can imagine that, for example, anchoring it to the bottom of the lake or sea or whatever, it can be very challenging, right? So how do you do it?
Yes, and this is one of the advantages with the way we do it also, because we typically use maybe a gravity anchor, or it's a clump weight or big concrete blocks, and then chain going from that, and then it's on the part that can sit on the seafloor, and then you have ropes and going up the buoys, and then mooring lines connecting into these rings.
Okay.
And because of the rigidity of these rings, you can use fewer of these mooring lines. So, and then some of these hydro reservoirs are going up and down quite a lot, so they have large level fluctuations in those lakes. And then it's important to maintain the lateral position of the whole solar farm. And so that is how then it's not really visible, but it's so-called catenary mooring. So big chains and mooring lines hanging into the lake and down to these gravity anchors.
I think that,
and the whole thing, this is one of the, we have in our company several naval architects. So this is one of our specialities, actually, to do the hydrodynamic modeling and analysis. So we take into the meteorological reports the so-called metocean data, the sea state, and then we calculate these mooring forces and how to lay out your solar farm as a function of wind, wave, and current.
That actually sort of answers a question that I had, which is how different does the installation process look like, for example, between a lake, which might not have a lot of wind, or might not have a lot, and the sea, for example, which has waves, and which has tides, currents.
This can differ quite a lot, and not only those things, but also the so-called bathymetry. That is what it means, the topology of the seafloor. So we need to map out that. And then to dimension the exact lengths of these anchor lines and everything, and also to characterize the seafloor and what type of anchors are suitable for that location, etc.
Interesting.
So this we put a lot of effort in, and the whole purpose of that is also then to comply with our so-called design premise, which is then ratified or certified by, or approved by these so-called class societies, the DNV and Bureau Veritas. You have these institutions that they sort of check your calculations, and if you have a new vessel and you need to insure it and make it bankable, so to say, you have these third parties that check your calculations and approve of that, and that is all then acknowledged by the insurance companies, which then is okay to insure it, and then eventually the banks can finance these large solar farms. So we have spent a lot of work with these naval institutions that make these design rules and to work out the methodology of doing it. And it's very similar to these very big fish farms, for instance, which have a lot of high value assets inside them, and it's also considered biological disaster if some of these fish farms are destroyed in bad weather, because then you have the escape of farmed salmon mixing with the wild type salmon. It's highly undesirable, and it's a big fines and everything if that happens. So the rules for making this is quite stringent, and we use those principles in the same way, because we think then this is the road to making these fully bankable systems.
Wow. I was actually going to ask you precisely about these finance, because traditional solar panels, especially large-scale farms, are already quite expensive. So one of the big selling points of them precisely is the fact that, of course, the amount of electricity you're going to generate is going to, within a time frame of a few years, sort of going to catch up with what you paid for the project, right? That's the basic premise of this. So how does that look like for one of these floating systems? How long will it take for the investors in this case to get their return of investment, pretty much?
So, and that's the main or the big question. This is the price of energy, but that's what's fantastic about this, is that with these really low prices on solar panels now, and you have this tremendous manufacturing capacity coming up with this then the floating is marginally more expensive than put them up on the land. Yeah, it's almost comparable with using these techniques with these large membranes, because they're relatively big, inexpensive surfaces.
Okay.
And if you are, then it's also a function of the irradiation or where you are. If you are in a place with good solar resources,
of course, that's
perhaps in the lower latitudes, then you can earn back this investment in a year. And especially if your alternative is to produce energy on a diesel generator, which is very expensive. So there are some fantastic investment opportunities with this for if you have demand and sitting, for instance, in some of these Pacific islands and those places.
That is very cool. Wow, thank you very much for sharing that. I didn't expect it to be so comparable, honestly, to regular installations. So that's very cool to know. Now, coming back a little bit into the tech itself, all right, sort of moving past this finance part, which is very important. I'm very curious about the maintenance, how maintenance looks like for these panels, because I really like comparing this to a traditional sort of a traditional installation, because in the end, that is what most people are going to see in their daily lives and understand a little better. Maintenance looks like typically you have years without really having to do anything, maybe just cleaning up a little bit. But in the electrical side or in the actual, like the structure wise, there's not a lot to do. In this case, I can just imagine or assume that the fact that you are on water, there's going to be some added degradation to it. Not necessarily the winds, but the water itself, I would assume. So how does the maintenance and the overall durability of these look like in the long run?
Yeah, and it's very important. And this is, of course, the uptime and the performance of the system. And this can be, it's often the term soiling that is used. And you can have different sources of this. It can be airborne pollutants, it could be dust or bird droppings.
Right, that's very typical.
And for the floating also, you need to consider marine growth or fouling of barnacles or water plants,
Oh,
what have
okay,
you,
yeah.
that can attach to your floating system. So for the latter, then it's important to have this using materials with a proper anti-fouling coating,
Yeah.
or having surfaces that it's difficult for these barnacle to attach to, and
Yeah.
so you can do things like that. But even so, you occasionally you will have to go and do some cleaning of this, or scrape off something. But these textiles are very good in that sense, because it's a complete darkness underneath them, and it's a very slippery surface that is not. It's very good against fouling.
Mm.
And then when it comes to birds, sometimes you need to put up these bird deterrents, or crows, or
Yeah.
you have different methods for doing it. You can have these transparent lines, or these kites, hawks, things like that,
Okay.
and also to look at some of them. Sometimes it's migrating birds, so you have
Yeah.
to maybe watch out for this a couple of times a year, and you
Wow.
can also have what we have experienced in south of Europe. Sometimes you have these big dust storms from Sahara Desert,
Mm-hmm.
and then you have this very fine dust high up in atmosphere that is carried with the jet streams very
Yeah.
far distances, and sometimes this is coming down in rain or deposits. So what we then do is, if it's not normal rain, then we can also add clean water on top of these surfaces, and to clean out
Oh,
dust
right,
or
right.
particles like this. Yeah.
Yeah, but that seems like a
So
very regular sort of just, cleaning, wiping it pretty much. But actually, that does raise one quick question. So these floater containers, I mean, of course, the idea is for them not to, take any water. So when it rains, do they have some sort of draining system so that water doesn't stay like attached to them?
yes, yeah.
Oh,
So on top of the surface, we have these surface bilge pumps. These are automatically operated. They have a so-called
oh, okay.
float switch. So they sense, okay, it's raining, and it automatically starts, and then
Oh,
it
cool.
collects the rainwater that falls on top. And if you are in a freshwater lake, it just goes overboard. But
Okay.
if you are on, let's say, on an island where you have infrequent or little precipitation, then we can also save that fresh water.
Oh,
And
wow.
yeah, and you can go, so you don't need to do the desalination. Lots of energy in many islands are consumed for desalination plants, but this is
Wow.
huge catchment area. So we then they can collect the rain, fresh water.
Yeah, it makes perfect sense. Best of both worlds. It's amazing. That's
Yeah.
that's pretty cool. Thank you for sharing that. In fact, precisely speaking about this, now I want to sort of touch a little bit more about your creative mind, and let's speculate together. All right, in a sense, let's just speculate together. Very recently, we had Rins Lesman on the podcast. Okay, around a month ago, and Rins is his company is building sort of these energy generators, right, from wave power, pretty much, right. So they put them
Yeah.
on the shore, pretty much, and then just the wave, that pulls up and down their devices. That is what generates electricity. It was a very cool podcast. Um,
Yeah.
so when I saw these floating solar panels, I was thinking, speculating just for the sake of engineering thinking, if you will. Uh,
Yeah.
do you see possible that these type of installations, because of the very wide surface area they have, can they be sort of part of a bigger modular type of energy generator farm, if you will, that might include, for example, those systems that I just discussed, that are these wave embracing energy generators, or wind, perhaps, if maybe there is a more robust area where to put them, etc. Do you believe this could be part of a larger system, or because of the size that this already takes, because it's very large, is that sort of
Yeah.
not possible?
Yeah, of course, you have with, like many of the renewables, you have the problem with the intermittency. Like, I mean, solar, it's only producing at day, and wind, you need
Yeah,
wind.
and even less hours at
And
100%
also with
efficiency. Yeah,
wave power, you don't, very few places you have constant big waves,
yeah,
you
yeah.
know, so it's a intermittency. And and sometimes it's favorable with this so-called hybridization, so you can have different sources. So we have been working with this also in China, actually, but combining the floating solar with an offshore wind turbine. So then experimenting with connecting to the transformer inside this monopile, this were bottom fixed wind turbine, and then so then they can share the same transmission line to shore, and then you have a better utilization of that existing infrastructure. And you can do that also with the wave power and so, but the floating solar is not, well, ideally you're looking for semi-sheltered waters, or where you don't need to dimension things that much, you know. So but you might see these combination power plants, I think, first and foremost with when you combine wind, offshore wind power with floating solar. Because they are also sometimes complementary. So oftentimes you have stronger wind at night, and so while producing more power at day, and also this having this floating solar on the hydro power reservoirs is also kind of a hybridization, because at night you can run turbines and you can save some of your water at the daytime when you produce solar power, or you can use this so-called pumped storage, where you can actually just move water up in at a higher altitude and thereby store energy for later use.
Wow.
So you will find these combination power plants, I think, and but sometimes they are better, for one of the type of energy generation than the other. But sometimes
That is very, very cool. Thank you very much. I didn't expect that answer. Like, I didn't know you were already doing it in China, right? With this hybridization sort of test, which is I'm very glad I got to ask this, but it's also very cool to know, or to see that this is going to be definitely a very common thing in the future, right? I mean, at least we hope. So thank you very much for sharing that. Now, I want to ask the third part of these questions, which we already talked about installation, we already talked about maintenance, and rather than maintenance, also we talked a lot about prevention, which is very cool to know that you do a lot of prevention for things that people would probably never really think of, like birds, migration, etc. Now, the last one is, I'm very curious about how this could potentially affect, or how this changes the landscape of the marine, in this case, world, or you know, the fish that live in the sea. Because especially if it's a very reduced size lake, for example, I would assume that cutting off a big portion of the light that comes into this lake can be it can change drastically. So how does this work in your research? What sort of changes have you seen done to the not the environment generally, but to the specific, you know, life forms in that lake, or I mean, the sea maybe not so different because there's just a bunch of water around. So how does this look like?
Yeah, and I think it's your last point. I mean, the largest of these demonstration units, it's not really, if you look at let's say a super tanker, 400-500 meter ship, you know, that it's casting more or as much shadow as one of these.
Yes, definitely.
So and at sea, in the ocean, I think it's the relative surface that you cover is so small that it's not really,
it's neglectable, if you will, right?
Yeah, and at least at some water depth. You don't want to put it on a beach where you have corals at very shallow water or something that it can make a difference. But in the lakes, it's and also in, like here we have in Oslo, Norway, we have the Oslo fjord. This fjord is suffering a lot from what you call nutrient runoff. And also sometimes you have this in big lakes. You have from the farming, you have fertilizer or nitrogen, very high, it's rich nutrients seeping into the lake or the fjord. And then you have these sudden algae blooms where you have the sudden growth of these algae. It's driven by sunlight and this very nutritious water. And then when the algae rots in the autumn, and then it consumes a lot of the oxygen in the lake. Because of bacteria, and it also produces sometimes these poisonous cyanobacteria, which then people can't go swimming because it's these are dangerous algae or byproducts from these algae. Blue-green algae, sometimes called.
Okay.
And what the floating solar then can contribute to reducing because it takes some of the sunlight, but normally you'd cover maybe a few percentage of the surface of a lake, and normally this is regulated. So and you have very high power density in these, so you have such large surfaces and they have a relatively small area, but we think it's actually contributes in a positive. It improves water quality in the most water bodies, and it can be used for these so-called destratifiers.
Okay.
The stratification in lakes or fjords is that you have different levels of oxygen concentration as a function of your depth, and sometimes at the bottom, like in the Oslo fjord, we no longer have the cod. It used to be very rich fisheries and a lot of fish, but most of the fjord is completely dead because of this stratification. But it can be mitigated if you then take the power from the floating solar, and then you pump the oxygen-rich surface water into the depths of the fjord, and then you can re-establish good habitat for the fish and improve water qualities even further.
I did not expect that answer. It's really cool. Thank you very much for sharing that. Now I'm very curious, does this mean that you sort of do, whenever you're planning to install something of this, while you're in the research and planification process, does this mean that you select the water body you're gonna put this on, sort of like preferably in a place where it's gonna have this type of positive impact? Because I would assume that a lake that it already is rich in nutrients and full of multiple water life body, I would assume that this isn't gonna see that many benefits. Sorry.
I think these are kind of byproducts of this, but in all these projects, authorities in all countries and everywhere we operated, it's very concerned about the same questions, and always there is an environmental report. You have marine biologists looking at this way before these are built, and or the limnologists if in case of inland waters. So you have and people with expertise in the local biosystems. So but they also are aware of these opportunities that it can be used for improving. So it's rather than having this immediate thought that this is negative or not good, that it's actually mostly the opposite. It creates it can improve.
Wow, that's amazing to know. You've really thought of everything. Definitely. I can only imagine how, like the first time, for example, you presented this report and somebody was like, okay, but give me a marine report or a biology report, and you're like, oh, I have to do that as well. Like the first times of this, I can just imagine what a journey and a challenge they were.
Yeah, we are not really biologists ourselves, so these are external specialists.
Yes, of course.
That are hired for these specific tasks. So, but we work together with them. And so,
I can just imagine like the first times you have to face these challenges. It's really cool. Now, I believe that I mean, we've learned a lot of the way that this technology works, and I think that we are nearing the end of of this interview. But before that, I want to ask a question that I already know the answer to it. Okay, I understand that the reason why your tech is circles is simply because it is the geometry figure that takes the better that you can take a better bunch of in terms of the area, right? The surface area.
Yeah.
But I'm very curious. Has anybody asked you, or have you thought of building differently shaped, rims, like a triangle, a square, or maybe even different shapes, sort of to embrace tourism and add visually to the landscape?
Yes, and some and we get this question a lot and many times. And you can do that. You can build them these rectangular or hexagonal or what shape you like.
Yeah,
But there is something attractive with these circles because first of all, they are easy to produce because
yeah,
the pipes are continuous. You don't need to have these junctions and make more complicated
yeah,
geometries out of them. And if you have these strong waves or wind and these things, then the circular shape is very favorable for
mm-hmm.
the distribution of the forces. So you can imagine if you had a big rectangular shaped floater, and then you have one day a wave front or wind direction that is coming directly into one of the broad sides of that
Mm-hmm.
square structure, and then you have uh, then it will start to compress, and you need to do something with your mooring arrangement to maintain that rectangular shape.
Right, right.
Otherwise, it will, and you will very soon discover when you do the simulations in the hydrodynamic analysis tools, you will see that it's not as efficient as the
Yeah,
circular shape, and where it's almost like load distribution in a wheel. If you have a wheel and then you press it on one point, then you engage the whole rim in translating those forces. So that is kind of the beauty of these circles, and
yeah.
that is the reason for making them like that. And oftentimes, or most normally, it's possible then to arrange these circles in more, like in the
Yeah,
picture, it's densely packed.
it's very
So
pretty. It looks nice.
yeah,
It's attractive. Yeah.
it's like a group of water lilies, So that
Uh-huh.
it's in this biomimicry shape that it's we think
Yeah.
it's a good way to do it.
Yeah, no, it's definitely a good way. I mean, of course, you have to go with the shape that makes the most sense. I didn't really expect the one of the reasons to be the force distribution, but it makes total sense when you explain it. But yeah, I mean, I was just very curious to know. I'm glad to know you have already made simulations of this, which means that this has been at some point been something serious. It makes total sense to be circles, but it's funny to imagine at least the idea of maybe, I don't know, like a star shaped one, But
Yeah.
it's interesting. It's interesting to think of it.
Yeah.
But I mean, that's very cool.
You can do that, but we also optimize the amount of these
Of course.
pipes relative to your surface.
Right.
Also.
Yeah, definitely. And yeah, the perimeter sort of or surrounding it, that makes total sense. And I mean, that was just a very curious and funny question that I had. Thank you very much for answering it. And I believe this is the perfect way to end the interview, except we have one last question. Okay. And this is a question that I want to ask you because of two things. Number one, because you're the CEO of a very cool company. Okay. Like this technology that you're building is incredible, not just visually because it looks amazing, but also it is so broad, and the type of engineering behind it is so large. It's very cool. That is one side, and the other is because you have a really cool background in research, as in engineering. You have a preparation in this, like you even worked at the Sintef. It's amazing. For those of you who might not be familiar with this, I mean, I studied engineering myself, so I heard about this, and I read a lot about it. It's basically the Sintef is it's, I believe, Norway's largest research institute, like it's an organization, not for organization, sorry, right? It's multidisciplinary.
Mhm.
You
Yeah.
were a researcher there. It's amazing.
Yeah.
You have a really
That
cool
was
background.
back in it's many years ago, but SINTEF, yeah, it's several thousand researchers actually, and working very closely with university, technical university, and
Yeah,
yeah, it's quite known internationally, and also very
yeah.
strong in the maritime. They have something called SINTEF Ocean, and they have
Oh,
one
I
of
didn't know that.
the most advanced basin laboratories in the world.
Oh,
These very huge basins where you can
uh-huh.
generate all type of waves and conditions, and to test out
Wow.
various boats and vessels. And we have been using that facility a lot to qualify
Yeah.
these, and they also do a lot of research on this type of membrane
Well,
type
look at
floating.
that. I didn't know that. I didn't know we're so big in maritime, and I definitely didn't know they had that that facilities. That's very cool. Thank you. Yeah, I was just very cool. It was very cool and exciting to see that you worked there as a researcher, because back in my university days, in my engineering, I was looking, for internships and everything, and this just and the name popped up. So it was cool to see a familiar name.
Yeah,
Anyway, the reason why I brought it up is because you have a very cool background with very diverse background as well, right?
thank
So
you.
the question that emanates from all of this is, what advice would you give? What advice do you have for, I want to say, maybe a young entrepreneur or a young engineer or a young person maybe who is interested in science or being a researcher? What advice do you have for this young starting person that want to set their own path, maybe on their own company or maybe as a researcher or an engineering wise? What advice do you have?
Yeah, it's a very good question, but I think it's just to do things that you think are, or that you like, or you think are cool, because it's so much more motivating to work with, and then work becomes more, let's say, fun, and then it's easier, I think. And I think it goes with all professions or things, that you have to
Yes.
do what you like, or and think are cool. And I'm so lucky that I think these things are very important and cool. New stuff,
Yeah.
big new floating renewable power plants. It's a few things that are perhaps more important to advance these days, and
I agree.
I think it's a fantastic area, and there is always opportunities in whatever field or area of science that you work. There's always new possibilities and opportunities to develop things. And if you ever get the chance to start your own business, it's highly recommended. I've worked 25 years in corporate
Yeah.
big companies. It's of course also, you learn a lot from doing that, but if you also get the chance to work for yourself, or to found your own company, that is highly recommendable, and it makes at least your job very exciting, so to say. Yeah.
That is amazing. Thank you very much for sharing that. So you already heard it. Just find something that you feel is really cool. I know that was gonna be the last question, but I have just one little extra, just the last one, okay? Which is, how did you feel when you finished and finally saw the first time you installed these circular installations floating at sea? How did you feel saying that was me?
Yeah, well, we were already, at the time, we were a group of engineers doing it, but it's a fantastic feeling. It really is, and also very visible.
Yeah,
So yeah,
yeah, it's
but
definitely
you
very.
also have setbacks. We have things that are not working, and also the process of building them. There's so many things. So, but certainly, and the first time we actually realized that we could walk uh, essentially on
Yeah.
water, or on this, yeah, it was big sensation. Yeah.
That's very cool. Asking because I think that is a feeling that any young aspiring, not only entrepreneur, but also I think uh, not even engineer, just a person that wants to live our own tech should strive for, right? So thank you very much for that. That now I believe that is the perfect way to end the interview. Oh, you have a final comments? Sorry.
Oh, just thank you very much, Sam. I think
thank you.
I mean, the Build a Nation podcast is fantastic. I've seen most of the shows, and it's
Nice. Thank you.
really going in depth in technologies, and I think it's an amazing show that you have.
Thank you very much. I really appreciate that. Thank you very much. Now, before I let you go, Børge, is that a pronunciation better?
Yes.
Thank you. Before I let you go, where can people find you, and where can people find Ocean Sun? What are your social media handles? For I have to say, this tech is really cool. It's worth checking out.
Yeah, I think we are on all platforms. It's a YouTube channel, it's a LinkedIn, it's Instagram, and also the oceansun.no.
Yeah, the website. It's a really cool website.
Web pages. Yeah, that's it.
Really cool. It's very, very visual. So thank you very much for that, guys. It's already on the comments and in the chat. Go look for them. It's a really, really cool tech and company. The images, for example, your background image, there are just a bunch of videos that are just as cool as that. So that's very cool. Now, for anybody out there, please remember that you can find more information, interesting articles, more interviews, short clips, blogs, content, just a lot of content directly on our website, buildernation.io, and as Builder Nation across all social media. We're gonna love to hear from you. Thank you very much for being part of this community. Børge, thank you very much for joining us in this community. It's been such a pleasure to have you. And yeah, it's pretty much the end of the interview. Thank you very much.
Thank you.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic three-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building.